All right, so what we need to do here is says find the x-intercepts and multiplicity of each. So the first thing we'll need to do is factor. So looks like I can factor out an x squared. So let's make this back to that color. So we'll have x squared times, and if we do that, that's x to the fourth minus 3x squared minus 4. Now we can factor this, I think. That looks like we have an x squared times. Now x to the fourth is x squared times x squared. And then we'll have a minus 4 and a plus 1. Now this one can be factored into x plus 2, x minus 2, difference of squares. And this one's still just x squared plus 1. So now what we have is we have the intercepts, and we have x equals 0, so that's going to be 0, 0. And let's write our multiplicity. And so that multiplicity is 2 because we have that 2 right there. Now then we have x is equal to a minus 2, so it's minus 2, 0. Its multiplicity is just a 1. Then the next one's x equals 2, so that's a 2, 0. And so its multiplicity is 1 as well. Now this last one, that's going to give us an imaginary number, and we only want real numbers, and so that's not going to give us an intercept. And so we just have those 3 intercepts with that multiplicity, okay? And so that's basically it's asking everything we've done, and so let's move on to the next one. So here we see there's a 3x squared in each term. And so if we pull that out, that leaves us x squared plus 6x, and then plus, oh, that's not 6, that's a 2, sorry. Forgot to factor out the 3. So that's a 2x and then plus 1. Well, that's 3x squared times. Now this is another perfect square, so that's x plus 1, and then quantity squared. So now we've got two factors, this, and so that means we have x equals 0, and then multiplicity is going to give us 2 because we have a factor of 2 here. And then if we wanted to write it out, that would be 0, 0. And this is going to be x equals, and this is going to be a minus 1. Its multiplicity is also 2. And if we wanted to write that out, that was going to be a minus 1, 0. So we have the two x-intercepts, their multiplicities, and they work because that adds up to our 4, and same as those multiplicities added up to our 6 if we considered that we had some imaginary ones there. So the 2 plus those 2 gives us that 6. Okay. Now we need to write a formula for the polynomial of least degree. We need to identify zeros and multiplicity. So let's first identify our zeros. So we've got one here, we've got one here. Both of those are multiplicity 1 because there's a straight line through them. And then we've got one here, and that bounces off, so that has multiplicity probably of 2. So let's say we have a minus 4, 0, and then multiplicity is going to be a 1. And then we have a minus 2 and a 0, and write that a little nicer. That multiplicity is also 1. And then here we have a 3, 0, and its multiplicity, I'm going to assume, is going to be a 2. Okay. Now we have a y-intercept of 0, 3, and that's going to be useful when we have to solve for that a. All right, so if we plug everything in we know here, f of x equals a times, and then we have x plus 4, x plus 2, and then x minus 3, and remember, multiplicity of 2, so that's squared, okay? Now we plug in our 0, 3, so 3 equals a times, and we plug in 0, that's 4, that's 2, that's a minus 3 squared, and so then we have 3 equals a times, here we have 4 times 2 is 8, here we have negative 3 squared, that's going to be a 9, 9 times 8 is going to be 72, so a is going to be 3 divided by 72, so 3 goes in there, 2, 4, and so 1 over 24. And so then it gives us f of x is equal to 1 over 24 times x, oops, that's not an x, times x plus 4, x plus 2, x minus 3, squared. And so that is going to be our equation. And we have a degree 1, 2, 3, 4. And so that means it should be going up because here that's a positive. And so our general form is like that because k is greater than 0. That's what we see here. And so therefore, we're pretty sure that that's going to be at least the polynomial of least degree. All right, so what about this one? This one's a little more complex than we've seen. We have 1, 2, 3 intercepts. So let's write those out. We have a minus 3, 0. And their multiplicity, that's going straight through. So that multiplicity is 1. Here we have a minus 2, 0. Its multiplicity is 1 as well because it's going straight through. Now this was the first time we have one that kind of does that, jig-jag here, and that's at 1, 0. And so remember, that's odd, and so it's going to be 3 because it's not linear. It kind of goes to an odd angle. So the minimum is 3, could be 5, could be 7, but we're going to say because it asks for what is the least one, that's going to be a 3. Okay. Looks like our intercept here is going to be 0, negative 1 for the y-intercept, which we can use to plug in for a. Now it's coming down and over and down, and so that's going to be overall odd degree, and it should be k is greater than 0. So we're expecting that when we get our equation done. And so now let's plug everything in. So f of x equals, and now we have a times, and then now we have x plus 3, and then we have x plus 2, and then we have x minus 1, and remember, it's cubed. Okay, so that's 3, 4, 5. It's odd degree, so that fits that part. Now let's solve for a. So we have a minus 1 equals a times, now we have 3 times, and now we have a 2, and here we have minus 1 to the third. Well, minus 1 to the third is just minus 1. And so then we have basically a minus 1 equals a minus 6a divided by minus 6. So a is equal to 1/6. And we have our k greater than 0, so that looks good too. So f of x is equal to 1/6 times x plus 3, x plus 2, and x minus 1 cubed. Okay, and so that's our polynomial of this graph here. And so if we plotted this, we would hopefully get something that looks very, very similar to that. And so let's do and see what we get. Now let me see, do I have this written down so I can write it later? Not really, but let's do it anyway. Let me write it down real quick. All right, let's go to do our new share, our calculator. Let's go to the y, let's clear that. Let's see if what we wrote or came up with will actually work. So we had 1 divided by 6 times, and we had x plus 3, x plus 2, and then we had x minus 1 to the third. And let's look at the graph of that. And let's kind of maybe window, maybe here, let's go, maybe do that one, minus 20, 25. All right, so if we remember our graph, it kind of went up like this, then down and over and up. And so yeah, that kind of looks like what we had as far as our graph goes. Again, it's going to be harder to see because we have this kind of spread out a little bit. Maybe if we would go to, I don't know, a -5 to a 5, and maybe by 0.5, and then this one from minus, I don't know, 5 again to 5 to 0.5. I don't know if that's gonna, yeah, so it kind of goes up here. That's 1, 2, 3, 4, 5, 6. So that's gonna be a -3. That's gonna be the -2. That's gonna be 1, 2. So it's gonna cross at the 1. and here it's going down at the -1. So yeah, it fits everything we kind of did it before. So that should be our actual equation of that graph. It's if we had the same scale, then it might look a little better. All right. So now we're supposed to confirm at least 1 0 in that interval. And again, all we're doing is we're going to plug in f of 1, and we're going to plug in f of 5, and that's going to be our first step. And then we'll see if those are opposites, we're done. We've confirmed at least 1 0. If not, then we have to kind of choose some numbers in between. So if we plug in f of 1, that's going to be 1 to the 5th minus 2 times 1. And that's going to be 1 minus 2, and that's minus 1. Okay, that looks good. Now this one's a little bit bigger because now we have to take 5 to the 5th minus 2 times 5. And 5 to the 5th, if I get my calculator out, that looks to be 5 to the 5th is, wow, that's a big number. 3125, and then minus the 10, that's going to be 3115. So that is positive, that one is negative, so they are opposites. And so there is a 0 between them. And I bet even if we would change that, instead of having maybe a 5, I bet if we even put 2 in here, what about x equals 2? So between 1 and 2, what would that give us? Well, f of 2 is going to be 2 to the 5th minus 2 times 5. And so 2 to the 5th is going to be 32 minus 10. And that's going to give us 22. And so, oh, whoops, I can't put 5 there. That's not a 5, sorry. I just saw that. Because we put a 2 now. 2 times 2, so that's minus 4, and that's 28. All right, so even between 1 and 2, there is a 0. So 1 and 5, there probably might even be multiple zeros, but even between 1 and 2, there is that 0 because there's also between there and there is going to be opposites. All right. Now we're going to do another application or two here. So the first one, we're looking at a right circular cone, and so it has a radius of 3x plus 6 and a height 3 centimeters less. Express the volume of the cone as a polynomial function, and they give us the volume of a cone, which is really nice, so we don't have to memorize that. And that's for r is radius and h is height. And so let's kind of draw a picture of what we have. So we have some cone, and so this is going to be r equals, and it's 3x plus 6, and that's in centimeters. And then we have this height, h, and that's equal to 3x plus 3, because it's 3 centimeters less than that, so that's 3x plus 3. So now we just plug everything in. So v of x is equal to 1/3 pi times r, which is 3x plus 6 squared, times h, which is 3x plus 3. And so now all we have to do is we just basically multiply it all together, and we can kind of simplify from there. One thing I do see is, to simplify this, if I take 1/3 times this, so let's go ahead and do 1/3 times 3x plus 3, and then times our 3x plus 6 squared. If I multiply here, that gives me x plus 1. And so that's going to simplify that first part a little bit. And then I can go ahead and square this. So it's going to be 3 times 3 is going to be 9x squared. And then 3 times 6 is 18 times 2, so it's going to be 36x plus 36. Now I can multiply that, so that's going to be 9x to the third. Oh, we still forgot pi here, so there's a pi on the end. So that's 9x cubed, and then plus 36x squared plus 36x. And then we have plus 9x squared plus 36x plus 36. And so that looks good. And so now we have x squared and x squared x. So that's going to give us 9x to the third, and then plus, now we have 36 in that, so that's going to be 45x squared plus 72x plus 36, and that's all times pi. Now, while this would be, one example, I see that there's a common factor here, and so if I pull out that common factor of 9, that would give me 9 pi times x cubed plus 5x squared plus 8x plus, and then 4, and that would make the inside polynomial easier. So when I want to take and plug in a number for x to get out the volume of x, it'd be easier, although it doesn't really matter. We still have to multiply by 9 pi when we're done. So, either one of those last two should be good. The last one might be a little nicer if you're plugging in values for x. The other one, you have to have bigger numbers you have to multiply by. So up to you, kind of depends on how you want, and also check and see what it says on mom or whatever to do there. All right, so another one where it looks like we have to maximize. So it says a square has sides of 12 centimeters. So we're doing square now. Oops. So we have something with all the same sides. And what we're going to do is we're going to cut out, these are, 12 by 12. We're going to cut out x plus 1 by x plus 1 centimeter squares out of each corner. And so we're cutting out the corners again. And those are x plus 1, 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 x plus 1. All right, so now we have all those squares we cut out, and then we're going to fold it up to create an open box. Now what we want to do is express the volume of the box as a function in terms of x, and then find the size of the squares that should be cut out to maximize the volume enclosed in the box. All right, so I didn't draw that very well. I think I shall start over. So all right, so that looks a little bit better. Now my height is going to be the cutout size, so x plus 1. Now the width and the length are the same. They're going to be the 12 minus x plus 1 times 2, because there's 2 of them. And so if I simplify that, that's going to be 12 minus 2x minus 2. And so that's equal to the 10 minus 2x. And so that's going to be 10 minus 2x as well. So length, width, and then height. And so now I just have to kind of multiply all that together. So volume of x is equal to, now remember, since it's a square, we could really just take our height, x plus 1, times the 10 minus 2x quantity squared, because those are both the same, the length and the width. And so then we have this. Now we have to multiply what's in there and square it. So that's going to be x plus 1 times, I don't know where the 1 went, but we'll put it back in there. 10 squared is 100. 10 times 2 is 20, times 2 is going to be 40, so it's going to be minus 40x, and then plus 4x squared. Okay, now we take and multiply that all by x first, so that gives us 100x minus 40x squared plus 4x cubed, and then plus 100, and then minus 40x, and then plus 4x squared. And now that gives us, if we write it in decreasing order, 4x cubed. And then we have minus 40 plus 4, so it's going to be a minus 36x squared. And so then we have a minus 40, wait, we're on x's, minus 40x, and then plus 100, so that's going to be plus 60x, and then plus 100. So that looks like what we should have as far as our equation as a function. And so that's the first part. Now what we have to do is we have to plug that into our calculator, and we have to do the maximizing. And so let's share the calculator again. So y equals, let's clear that. And we had y equals, we have 4x to the third, and then we have minus 36x squared plus 60x, and then plus 100. And so if we graph, well, we probably should put a window. It's probably going to be about maybe, let's try minus 100 and do 100 and maybe by 20s. And just because I don't know where we're going to go, oops, not 1,000. And then 100 and by 20s. Now let's see what we have. All right, so we're not high enough. So we can go from maybe max minimum. Well, we don't need that. So maybe negative 20 to 20 and by 5. And minimum, we can do negative 50. Maximum, maybe do 300. And maybe it's by 100. Now let's see what we have. There we go. And so now what we need to do is we need to find that max at where the peak is. So we're going to do our second trace, and we want the 4, we want the maximum. And so that's a good spot there. Let's just enter there and go over to the other side, enter there, and let's kind of see somewhere in here. So it looks like 128. So that looks like that's going to be our max. So x equals 1 and then 128. So let's get that written down over here. So x equals 1, max is 128. And so now let's kind of write down what we have. So the maximum volume equals 128 centimeters cubed, because these are still centimeters. And then x equals 1 is the centimeter, but we have what size is the square. So it's 1 plus 1 is, so it's 2 by 2. So the squares are 2 centimeters by 2 centimeters that we cut out. And I think that's all it's asking for. It says find the size of the squares to be cut out. So that's going to be that. That was the max volume we actually get is 128 cubic centimeters. And that's going to be our function. Okay. And that's all I have for the extra examples.